Hello class, this is Mr. Hart. And in this video I want to talk about one of the most important applications of optics that we have not discussed yet, and that is photography. Now if you think about all the ways that we've been affected by being able to take images in videos, photos, etc., photography has been a huge aspect of life, especially in the past 100 years as we've developed more and more technology for capturing light. And so I want to talk about how photography came about and what it is and how we use optics to our advantage when we're doing this. So the first thing we need to understand is a little bit of the history of where it comes from. And so you probably know a camera. Well, a camera actually comes from the phrase camera obscura, which was one of the first ways they tried to actually do photography. Now, they didn't have any special film or anything like that, but what they would do is they would build this box, this completely dark, empty box. And inside that box, they would put just a little hole for light to enter through. And the result is as the light would come through the box, it would basically make the image on the back of the wall. And so what they could do is they could start drawing out and outlining manually what was on the wall, but they were basically taking a really slow picture. And so they would do this to get the light as an image on the back of the screen, and then they would draw out the information manually. And this is really one of the most basic ways to capture light. It's the pinhole camera. And so you have a box of some kind, you add a hole into it, either small or large, depending on how much light you want to come in, and then the light appears on the back of the box. Now, obviously we don't draw those manually by hand anymore. That takes forever. So we've developed other ways to actually get the light to imprint on the back. And one of the first ways to do it was with a film or something like that that would actually imprint the light on the back. You would go develop it, and then certain chemical reactions would cause the places where the light had been to come out, and the other places would not. And so you'd put it in some type of trough with this special chemical combination to get your image. But either way, it's the same idea. You have light come in, you have something on the back to capture that light, and the upside down picture is what you capture. And so nowadays we don't use just a pinhole, we use an actual optic. So let me show you this video. I showed it in the first video, but you can think of light as coming in, and as it comes in, it actually gets reflected by this lens. And so that lens replaces the pinhole. It has the same objective. It only allows a certain amount of light to come in, but now you don't restrict yourself to a very small pinhole, and you can get all the light on that back part of the camera. And it's crazy to think about, but this is actually what your eyes do as well, right? Your eyes aren't pinholes, but they're actually little lenses, right? I'm wearing glasses, but if you think about your eyes, they're kind of spherical in shape, and they act essentially as a lens. And so the light bends in and gets received on the back of your eye, and your brain receives those signals and processes it. So just like in this video, you actually see everything upside down. You just don't realize it because your brain autocorrects for you and flips it right side up so that you can navigate. And so from there, we've developed more and more cameras that use lenses. And those lenses allow for all sorts of combinations of focuses and things like that. And so the most common kind of camera is called a single lens reflex. And what it does is it allows all those lenses, it could be a combination of lenses or a single lens, to go through. And then there's a mirror to show you what it will look like. Okay, so here's my SLR, or well, what you would now call a digital SLR, right? A DSLR. And there's this viewing port right here, right, where you would look to take the picture. That's the same as this piece right here. So while the light's coming in, it's actually bouncing off this mirror. It bounces off this set of prism pieces till it gets to your eye. So you can see what the image is going to look like before you've actually captured it. Then once you press the right button, right, you take the picture, you actually press that button down, and you can hear, oh, let's try that again. Take the lens off. You can actually hear a click. right? I'll do that one more time. Hopefully you can hear it in the camera. Okay, and that little click is actually the mirror flipping up so that it's no longer blocking the light, but it's actually going to be exposed on this film in the back. Okay, so when you take a snapshot and you hear that click, it's actually this little hinge moving up out of the way so that it can be received on that back film. And like I said, nowadays we don't have SLRs, we have DSLRs, meaning that we just don't use a film anymore, we use a digital chip, which I'll talk about that in a second. But the process is still the same. You have a lens system going through, there's a little mirror on the back that brings up the light so you can see it, and then when you're ready to take the picture, you press the button, it closes the mirror up to the top, and then it's received on the back sensor. Okay, so I thought this was a pretty cool photo to see the inside of a digital camera. Now, one of the main reasons why a DSLR is super nice is that you can actually refocus your light. And basically, this is why we decided to go to optics instead of a pinhole, so you can decide where that light is going to focus. So let me illustrate this with another video. So if something is in focus, it means that all of the light coming from a single point should show up in the same spot on the back collection device, whether it's the film or the sensor. But if you just move that object a little bit in or out, suddenly all the light from that point will not collect in the same spot. It will kind of divert from that spot, and then you get something that's out of focus, which is a little bit blurry. And so the benefit of having an optic is that you can move that optic in and out, and you can combine optics in certain ways so that you can change the focus location. And that's why if you take your DSLR, you have this piece right here that can move this in and out to zoom. You can move this left and right, which adjusts the lenses inside. So you can place things in and out of focus. So that's a really nice reason to have a digital camera that can move with an optic. So you can change that focus in and out. One last thing to realize is, again, we don't use film anymore. We use what are known as CMOS chips. Okay, their close cousins are CCDs, which were their predecessor. But the idea is the same. As light comes in on the chip, they look kind of like this. They're very reflective when you look at them in normal light. But the light comes in, and each part of the chip actually has a little filter on it of blue or green or red. And so it's only accepting certain colors of light. And as the light comes in, each one of these sensors picks up the certain amount of color that it wants to. I think this is showing that this one's picking up green, this one's picking up blue, this one's picking up red, etc. And then these four together actually make what we would call a pixel, right? You combine these four, you average the four values from these four spots, and that one pixel color is how much light you got in red, how much light you got in blue, and how much light you got in green, which can reconstruct the color that you're seeing. And so they sense the voltage of each light color they're getting, you combine those, and now you can capture the image in color on these CMOS chips. So they're really cool because they're totally electrical. They're just measuring light intensity coming in, and so you don't need a film anymore. You can just use a digital chip to capture the image. And that is really when photography took off. And now we see it inside of phones all over the place. And anyone can take a picture nowadays, and you don't have to wait for it to develop. And it's a very awesome piece of technology that we have at our fingertips. One final note that's cool about phone cameras is there's not room for a huge set of optics like this, right, on a DSLR. So how does a camera decide what's in focus, what is not? Okay. Well, it actually does have a little bit of zoom in and out that it can use, but it also has a lot of just digital things that it's doing to capture the image. It uses something called a rolling shutter, so it's just constantly accepting light, and then when you press the button, it just happens to capture what's on the sensor at that moment. So there's a lot of interesting things you have to do for phone cameras, but still the same idea. You have a CMOS chip, you have a lens, you can move it in and out slightly, and suddenly you're taking pictures. So a very, very powerful application of optics is the ability to use it to take photographs, and that has just changed our world dramatically. So I hope you've enjoyed this, and thank you for watching.